My name is Ebba Carbonnier. I work as a director for the Swedish Quantum Life Science Center. And I'm based at Karolinska Institutet in Stockholm. It's a medical university. And I'm going to talk about Swedish quantum technology. I won't go into all the details in our Swedish quantum agenda because I don't want you to fall asleep. So I'll take a little bit of a different approach to this. And it's a pleasure to be here as well. In 2019, I was the only Swedish person here at Quantum to Business. But now, thanks to Åsa Wallin and the Nordic Innovation House, we have a Swedish delegation. I'm really happy with that. Thank you. So I will talk a little bit about who we are, actually a little bit about the Swedish people as well, so you get to know us. And then our Swedish quantum community and what we have and what we do with our quantum technology. So who are the Swedish people? We're not the Swiss, we're the Swedish people. We have our festivities like midsummer. It's midnight sun, so you can go wakeboarding in the middle of the night. We give out the Nobel Prizes. That's a great party. We have fantastic forests. We have clean water. And in the winter, we have an ice hotel. And we have some innovations as well. Maybe you've heard of Minecraft, King, Candy Crush, Battlefield, adjustable wrench, roller bearing. That's in quite a few places. IKEA, maybe. Bluetooth. How many of you use Spotify? Yeah? That's a Swedish invention. And of course, coming into our quantum technologies. And when we talk about our quantum technologies, I would also like to mention that there are a few countries, rather 10, 12, 13, that have been selected for a multilateral group that have fairly good development of quantum technologies. And it actually matches very well with these most innovative countries. And the Swiss always beat us. But Sweden, US, we compete for number 2. This year, we're in second. So we beat US this year. So yes, fairly innovative. And we started with our quantum technologies and developing our quantum technologies 2000, of course, it was in different labs before 2017-18. But in 2018, we're really thankful that the Wallenberg Foundation, the Knut and Alice Wallenberg Foundation, funded the Wallenberg Center for Quantum Technology. And there's a reason that there's a flag there on the black supertanker, because that is actually our flagship in Sweden, WACT, Wallenberg Center for Quantum Technology. So thanks to that, we have development in many areas. And our user companies, for example, AstraZeneca, Jeppesen, which is now a Boeing company, Ericsson, Saab, Volvo. And then, of course, we have our centers and our funders and our startups, of which quite a few of them are here. We're very happy with that. So what do we have in terms of hardware? We have a quantum computer. We have 25 qubits at the Wallenberg Center for Quantum Technology, and it's superconducting. We have our own nanofabrication, and we're developing a test bed, both for testing hardware and, of course, application software and algorithms. And then on the sensing side, we have many labs for example, microscopy and spectroscopy. And then on the communication side, we have labs for the quantum key distribution and the post-quantum crypto. So what do we do? We work with real problems where there is a pull as well. So, for example, with this Jeppesen, a Boeing company, we're working on logistics optimization. And of course, this logistics optimization can be applied in many areas, not least in healthcare. And we have quantum chemistry, where we explore the stability, the reactivity, the bonding, the binding sites within the molecules so that we can shorten the lead times for the drug development process. And we work on the protein folding problem because, of course, AlphaFold did a fantastic job in a bit of an end product that this is how it's folded. But we are very interested in the dynamics, in the process of the protein folding. Because if there is erroneous protein folding, that's not very good. We need to learn much more about why there is erroneous protein folding so we understand more why we get Alzheimer's and Parkinson's, for example. And then we have brain scanning in terms of magnetoencephalograph with optically pumped magnetometers. You can see it there with a helmet. And that is already in clinic, where we, for example, can see and understand more of epilepsy, the activity in the brain. And then we have, is it? Oh, yeah, look, well, a little dot there. This one is spectroscopy. So it's development to be able to see tissue oxygenation in the heart, which is very important for stroke, and also for early detection of breast cancer tumors. So these are just some examples of what we're working on, some of the use cases that we're working on. And what are some of the strengths then? And one of the strengths in Sweden that we are really working on these real problems. So we have our quantum technology expertise, and as we mentioned here, there are US selected 10, 12 countries for quantum technology expertise for collaboration. So it seems like we've got something here. And we are a little bit ahead within health and life science, for example. So that's why we started the Swedish Quantum Life Science Center that I'm heading. And an example of that, I'm based at Karolinska Institutet, and Karolinska University Hospital is number 6 in the world. So the combination really of real problems and working with industries, maybe that's one of our strengths. So that was basically what I was going to run through. And then you can come and ask me about the agenda, and I can take many hours and go through all the details in the agenda as well. And you're more than welcome to come and talk to me about the use cases and the problems we're working on. And thank you from the Swedish quantum community. I'm so used to saying quantum life science because that's what I work in, but Swedish quantum community. Thank you.